Hey guys, Dr. Cadell here. This is the distillation and mass percent sodium chloride experiment. So in this experiment, we're going to use a commonly used technique in chemistry to separate mixtures, and that's distillation. The idea being in this experiment, we're going to start with a solution of sodium chloride. And one of the things we're going to find out at the end of the experiment is how much sodium chloride is in that solution, its mass percent. In order to do that, we have to separate out the sodium chloride from the solution. And that's what distillation does for us. Basically what's going to happen is we're going to put our solution in this flask right here, and we're going to heat it up. When we do, I'll show you how it's all attached in just a few minutes. But this is going to be attached here. Everything's going to be stoppered up. As this heats up, the solution in here is going to start boiling. As it does, the water evaporates, but the sodium chloride stays behind. Just like if you're cooking in the kitchen or somewhere and you have some salt water and you leave it go a little bit too long and all the water evaporates, see that white crusty stuff left behind? Same thing here, that's a sodium chloride. And so what we're going to do is heat this up, water on its evaporate. As it comes through here, this is called a jacketed condenser. We have some cold ice water actually running through this jacketed condenser. The way it works is there's an inside glass tube and this outer glass tube, and the water is between the two. The vapor is going to come up through the middle of the inside tube. And now when it hits that cold tube, it's going to condense and become liquid again, and we're going to collect that over here in our 100 milliliter round bottom flask. And so what will happen is we'll separate out the water. At this point, this is going to be distilled water, which is actually very pure, and we'll have the sodium chloride left over. The idea being that if we weigh the solution before and then weigh the sodium chloride afterwards, then we can take the mass of the sodium chloride, divide it by the mass of the solution, times 100, that's the mass percent sodium chloride. Another thing we're going to look at, guys, is we're going to look at how pure this water is. And the way we're going to do that is we're going to measure its density and compare that to the known density of pure water. Now the thing is, density depends upon temperature, so we're going to have to measure the temperature of this water and then look up the density of water at that temperature. That's in the lab report. All right, so, and we're going to also look at the density of our salt solution. So what we have here is, this is a 3-neck round bottom flask, a distillation flask. So we have some, these are called boiling chips in here, and they're supposed to be in there. We're going to weigh them with the flask, so we don't care how much they weigh. What they do is they keep the solution from bumping, what we call bumping as it's heating up. And bumping just means we get these big pockets of vapor inside of the solution, and then they burst and throw stuff everywhere, which we kind of don't want. So I have my name on here. You're going to have your name on there. And the first thing we need to know is the mass of the empty flask with the boiling chips in it. So to weigh the boiling flask, we're going to use a cork ring. Put it on the balance and tear the balance. So now the balance says 0 with the cork ring on there. Put the flask in. And we're going to record that. That's the mass of the empty flask, which is going to be A1, the evaporating flask. 3 places past the decimal, little g for grams. Now, okay, what we're going to do is we're going to put the solution in there and get the mass of the solution, the unknown solution. So we're going to tear out the flask with the cork ring. So now it says 0 with the flask and the cork ring. Take out the flask. And just add all of our unknown solution to this. Now, it's an unknown, so it has an unknown number. So we're going to take this off, tape it in our data table. Now, if you're just getting the data at home, there's not going to be an unknown number. Don't worry about that. Pour all of our solution into our tared evaporating flask. Put it back on the balance on the cork ring. Close the door. That mass there is our A2 mass of salt water. All right. Now I'm going to connect this up. We still have to measure the mass of another thing, but first I'm going to attach this here. Now this is a lab jack, so what it does is it can raise or lower. This is the heating mantle. This is what's going to heat it up right here. And I want to attach this middle neck to our condenser. Now with this setup, we want to make real sure there aren't any leaks, because if there are, vapor is going to escape and our mass of our water won't be correct. We also want this to be tight. Sure everything's good. We have some glass stoppers that we're going to put into the other openings. All right, before we can turn this guy on, we're going to collect the distilled water in this 100 milliliter round bottom flask. We need to know how much it weighs because we're going to weigh it with the water at the end. So what we're going to do is, the cork ring's still on there, so I'm going to tear the balance. It says 0 with the cork ring on there. That's the mass of the 100 ml round bottom flask, which is A3. 3 places past the decimal, little g for grams. I'm going to attach the 100 ml round bottom flask to the output of the condenser. Hold it on with the test tube clamp. All right, so now we're ready to go. I already have cold water running through the jacketed condenser. Everything's attached. Everything is stoppered up. Good to go. So I have this is the heating mantle. It's connected. All I have to do is turn it on. And now we're cooking. So now that we have our distillation started, we're going to measure the mass of 10 milliliters of our same unknown solution. We get a little bit more of the same solution. We're going to use a volumetric pipette to measure out the volume. So it's going to be 10.00 milliliters, 4 sig figs from the volume. So to do that, we're going to use a weigh boat. So we're going to tear out the weigh boat first. So now the balance says 0 with the empty weigh boat on there. We can take it out. And remember, we let gravity pull out the solution. We don't blow it out with the pipette bulb. Touch the tip to the side of the weigh boat. Place it back on the balance, get that mass. That is our A4. 3 places past the decimal, little g for grams. All right, so now it's been distilling for a while, and almost all of the liquid has distilled over into the round bottom, 100 milliliter round bottom flask. So what we do is we lower the lab jack. This takes the heat away immediately from the distillation flask. Turn off the power. We're going to let this cool down because it's still hot. At this point, what we do is we take off the 100 milliliter round bottom flask, and we're going to weigh this to see how much it weighs with the distilled water. So we're going to take the cork ring again. Place it on the balance, tear it out, so now it says 0 with the cork ring on there. Just put that 100 ml round bottom flask with the water in it. Record this mass 3 places past the decimal, little g for grams. This is your A5. Once we do that, we're going to measure the mass of 10 milliliters of this same distilled water. So to measure the mass of 10 milliliters of the distilled water, I'm going to use a volumetric pipette, another weigh boat. Place the weigh butt on the balance and tear it out. Now it says 0 with the weigh butt on there. And I'm going to pipette 10.00 milliliters of the distilled water into the weigh butt. Place the weigh butt with the 10 mils of distilled water on the balance. Record that number 3 places past the decimal, little g for grams. That's your A6. Now what we have to do is measure the temperature of our distilled water. So we're going to take a digital thermometer. Turn it on, make sure it's on degrees Celsius. Record this temperature. This, of course, is 1 past the decimal, degrees Celsius are the units. This is going to be A7. Now what we do is we're going to take the distillation flask, the evaporating flask, which should be cool enough now. Unclamp it. Take the stoppers out. Now we put this in the oven and we're going to let it dry until next week. When we come back, we'll weigh the flask with the salt in it, and that'll be our A8. That's all there is to it.